For this video, I'm going to walk you through how to solve problems when we have a horizontally launched projectile. Your goal by the end of this video is to understand how to use kinematic equations to solve problems involving something that is launched horizontally. Okay, remember, if we launch something horizontally, it has both a horizontal component and a vertical component. And the actual path of a projectile is a combination of both that horizontal and that vertical motion, so it follows a parabola. Understanding that horizontal and vertical motion are important in being able to set up our problems. Okay, let's solve for the following scenario. Okay, imagine you're playing a game of pool, and a pool ball is going to leave a 0.6 meter high table with an initial horizontal velocity of 2.4 meters per second. I want you to predict the time required for the pool ball to fall to the ground, and also the horizontal distance between the table's edge and the ball's landing location. As with every problem we do, I want you to start with what we know. This time, though, what I want you to do is organize everything horizontal and everything going vertical. Okay, so if we start out with the pool ball leaving a 0.6 meter high table, what that's telling us is the displacement of the golf ball. I'm going to make that a negative number because it's going to fall down that distance. It also has an initial velocity of 2.4 meters per second. That's your velocity in the x direction. Just given the problem, those are the only numbers that are explicitly given to us. But I want you to think about what else that you know. In the horizontal direction, remember that the acceleration horizontally is 0 meters per second squared. If we can neglect air resistance, there's nothing that's going to cause that pool ball to accelerate left to right. In the vertical direction, however, all things accelerate toward the ground at a rate of negative 9.8 meters per second squared. Something else that we know is the initial horizontal velocity in the y direction. Because it was launched horizontally, its vertical motion is the same as if it were just in free fall. Okay, so let's think about what is it that we need to find. We need to find the time that the pool ball is in the air. Looking at what we have, using the vertical position and the vertical information is going to be our best bet. One of the equations that you have in your toolbox is the change in displacement is your initial velocity times time plus 1/2 gravity times time squared. Since I'm dealing with the vertical motion, I'm going to look only at the numbers that are in that vertical column. Looking at what we know how far down the object is going to fall. We know our initial velocity is 0. We know gravity is negative 9.8. So I need to solve for time. Hit pause, type this in the calculator, and make sure you're going to get the exact same answer that I do. When I work this problem out, I get 0.35 seconds. Now remember, what's so special about this time is that's the same amount of time that we're being launched outward as well. So we figured out the time required for the pool ball to fall to the ground. Now I need to figure out horizontal distance. So the next thing I need to find is delta x. That's my new unknown. Since I'm dealing with displacement in the x direction, I need to look at what I know from that x direction. Looking at our toolkit of equations, we've got delta x is initial velocity times time plus 1/2 at squared. My initial velocity in the x direction was given to me in the problem. The time was something that I just calculated, but our acceleration in the x direction is 0. So to figure out our displacement horizontally, I'm just going to take my horizontal velocity times the amount of time that I'm in the air. Take the time to hit pause, type this in the calculator to make sure you're going to get the exact same answer I am. When I calculate this answer, I'm getting 0.84 meters. So that's how far that pool ball would hit the ground away from the table. Okay, we're looking at our diagram up here. That would be the displacement horizontally that I just found. Every problem you do, I want you to set up in a similar fashion. Organize everything you know in the x direction, organize everything you know in the y direction, and then keep in mind when we do an equation, we're not going to mix back and forth between the two. If I'm using an equation in the vertical direction, I'm only going to use numbers from that vertical direction. If I'm only doing a problem in the horizontal direction, I can only use numbers that are in that horizontal column. As always, if you have any questions, don't forget to ask me in class.